Welcome to session 4 of SQL Server Database Objects. In this session, we are going to learn about maintaining indexes. Let us see the session objectives. Define online index operations. Describe parallel index operations. Identify and explain the various options for locking. Explain indexes with included columns. Define and describe the partitioned indexes. Explain XML indexes. Explain how to disable an index. Explain how to drop an index. And describe the index statistics. Let's come to online index operations. SQL Server allows to create, rebuild, and drop indexes. The online option in SQL Server allows users to access data in the database or the base table during such index operations. The following structures are used for allowing concurrent user access to base tables during an index operation: source and pre-existing indexes, target, and temporary mapping indexes. Let's move ahead with source and pre-existing indexes. The data in the original table or clustered index is referred to as the source. All non-clustered indexes associated with the source are pre-existing indexes. For example, when a clustered index having associated non-clustered indexes on a table is rebuilt online, the clustered index is referred to as the source, whereas non-clustered indexes are referred to as pre-existing indexes. During the rebuild process, the pre-existing indexes are available for queries and modifications by the user. Let's come to target. The new index that is being built is referred to as the target. During the index operation, any modification operations such as insert, update, or delete performed on the source are applied to the target. This is done by database engine. For example, consider a clustered index is being rebuilt. Then all insert, update, or delete operations performed on this index during the rebuilding process are automatically applied to the new clustered index. We move ahead with temporary mapping index. When a clustered index is created, dropped, or rebuilt online, these index operations use a temporary mapping index. The temporary mapping index determines the records to be deleted in the new index when records in the base table are being updated or deleted. We come to online index activities. The source and the target go through the following three phases during the online index operations. The first is preparation, build, and final. Consider a clustered index being created online on a table with no other indexes defined on it. In this case, the table is the source, whereas the clustered index is the target. The source and target activities and concurrent user operations such as select, insert, update, and delete in each phase is done in the build phase. we come to the table that lists the source activities during each phase of the index operations. In the preparation phase, system metadata is prepared to create a new empty index structure. A snapshot of the table is defined. The write operations by multiple users on the source are blocked for a very short period. The TDL operations like create, alter, and drop are blocked, but multiple non-clustered indexes are allowed to be created on the table. In the build phase, the source scans, sorts, merges, and inserts data into the target. User modification operations like insert, update, and delete are allowed to be carried out on the pre-existing indexes and new indexes being built. In the final phase, system metadata is updated and the source is replaced with the target. The source is dropped in case of a rebuilding or dropping operations. The given table lists the target activity during each phase of the index operation. In the preparation phase, an index is created and only write operations are allowed to be carried out on that index. In the build phase, data from the source is inserted in the target. User modification operations like insert, update, and delete on the source are applied to the target. In the final phase, the metadata of the index is updated. Read and write operations are allowed on the index. We come to the degree of parallelism. SQL Server automatically evaluates the ideal degree of parallelism when processing queries for index operations. This evaluation is done based on the following criteria. First is the availability of multiple microprocessors on the computer running SQL Server. Parallel queries can be used only on computers that have multiple microprocessors. Second, the availability of sufficient threads for executing the parallel plan. If sufficient threads are unavailable, then the database engine automatically reduces the degree of parallelism. Third, the type of queries or operations being executed. For operations that heavily use CPU cycles, such as creating or rebuilding an index, the degree of parallelism is increased. Fourth, the number of rows to be processed. If there are not enough rows, then the serial execution plan is preferred. This is because in such a scenario, the cost of running the parallel plan outweighs the benefits.